As we're entering the new millennium, the landscape of scientific research is changing dramatically. Research is more and more interdisciplinary. One can't get away anymore with being a specialist, say in chemistry, as I was trained to be. One has to be able to have conversations ranging the gamut from mathematics to physics and clinical medicine. This is highlighted in some of the research that we do in our lab. And the beauty of being a graduate student is that one individual can cross all these thresholds and interact with people with diverse expertise. An example would be where the drugs of the 21st century are going to come from. We're pretty much running out of rainforests and the Pacific Ocean. They go into deep sea diving expeditions and get exotic species that happen to have these wonder drugs. But it clearly has to be done in a more systematic way to keep up with the challenges that nature throws at us. We have fantastic opportunities for improved health, but it's going to come from an understanding of disease at the basic level. A major milestone that's going to be coming up soon will be to have the entire genetic information of the human genome, the sequence of every single one of the 3 billion bases that encode for life. And some people think that's the end, but it's really only a beginning, because now we need to figure out what every one of those genes does. We need to figure out the differences between human populations that make some people more susceptible to diseases. We need to come up with tailor-made drugs for subpopulations, and we need to do this efficiently and rapidly. We need to generate many compounds and test them quickly. Sometimes this involves micro techniques, which are heavily based on physical principles. There's a tremendous amount of computer technology, developing smart systems to systematize what we as scholars have learned some rules, but now to do them, to free us of the mundane tasks so that we can concentrate on creating new knowledge and pushing the frontiers back. Things that were major accomplishments when I was a graduate student are now, and maybe took 4 or 5 years to write a thesis on, that can now be done by a student entering the laboratory after a couple of months of training. So progress is tremendous, and we need to keep up with it. And so to do cutting-edge research at a major research institution such as the University of Minnesota is a challenge.